Why I'm not ready to switch to Zig from Rust. You know, this Pekka fella, okay? I don't know about this Pekka fella, and I don't really understand this photo, why it has anything to do with that. I'm not going to lie. I love programming in C. He is a Linux kernel contributor, so probably not too much of a surprise that the man loves C, which is why I'm surprised he doesn't love Zig. I know it's a little bit irrational, but programming in C just feels right. Perhaps that's because I did spend a lot of time with C as I contributed to the Linux kernel. Those were good times because I had the opportunity to learn from some of the best C programmers in the world. Hacking on the Linux kernel also taught me the connection between C programs and the machine code it compiles to, which I guess influenced my thinking. Pekka built differently, confirmed. I know he's going to explain to me, but if you love C, the love of Rust feels confusing, okay? The love of C feels confusing. And the love of Rust. However, C is an unsafe language. It's easy to make mistakes. But I spent so many hours on debugging C programs that at some point I ended up being reasonably good at it. Classic, do something long enough and you get good at it. I was often able to trace back what happened just from the Linux kernel register dump, or oops, as they call it, and fix a bug that I was not able to reproduce. I also learned to write C in a way that minimized the mistakes. I felt productive with C. Type 1 in the chat if you are the same way. Do we have any C chads in here? Do we even have a singular C chat in here? We have a lot of people typing 1, and I just doubt it. I'm doubting seriously there are that many C chads in here. Segmentation fault. C is also a low-level language. When you're programming in C, you end up writing a lot of code just to do the simplest of tasks. There are no built-in data types, so I wanted a hash table or a linked list. I usually ended up rolling my own. I almost never used a binary search tree because writing one yourself took forever to get right. So perhaps C wasn't perfect after all. It is true. Hand rolling your own binary search tree is actually very difficult, especially when you consider deleting nodes. Like it's a lot of effort to get correct. Because the amount of little things you have to get right in a binary tree and all the links you have to touch, it's a lot of work. Balancing is the worst. Yeah. Like if you do AVL for balancing or red-black for balancing, dude, I can't even understand red-black that well. Like I've never done red-black in a full implementation. I've only done AVL in a full implementation. Red-black is fun. Maybe one of these days I have to implement a red-black tree. Because I've only ever done AVL. I thought AVL was a lot of fun. The world's balances on the most fragile things, and balancing binary search trees is most certainly one of the most fragile activities of all time. Red-black trees are just binary trees, and they have like 3 rules for balancing. Not hard. Yeah, I'm sure it's not hard. I know it involves like when you have a black uncle, you got to do something, but I can't remember anything beyond that. Like that's it. That's all I can remember about a red-black tree. See, if your node's uncle has a red color, then change the color of the node's parent and the uncle to black, and the grandfather to red color, and repeat the same process for him. If grandfather is root, then don't change the grandfather's red color. Like there's a whole set of rules you have to go here. People, just because you don't understand red-black trees, okay, it's showing. It's showing you don't know red-black trees right now. I did end up writing quite a bit of C++ professionally on 2 different occasions. The modernization effort that went into C++ 11 and subsequent versions made a big difference. Now you had access to a variety of data structures and algorithms, and with things like classes and templates, you ended up writing much less code. But C++ inherited the unsafety of C, which meant you still got to spend a bunch of time debugging your code. Okay? Skill issues. So in other words, it's easy to get skill issued. Absolutely. Rust memory safety and complexity. When Rust appeared in 2015, I was really drawn to its promise of memory safety, and then you got absolutely owned by async. I had done, by the way, in 2015, Rust was much more rough. Just use smart pointers. I don't know when smart pointers were exactly implemented. I want to say smart pointers were in 2011, but I'm not sure if they were. ASON, yeah. Most people just did ASON, of course. That's how we did it, right? Whoever just said that. Someone said ASON. Yeah. Just do sanitizer, address sanitizer stuff, and that usually does it. C++ had auto pointer, yeah. Most people just did that. At least that's what we did at Netflix. Caught some of my bugs I had in my memory analyzer was in using that. Valgrind, yeah, I did some Valgrinding for sure. I had done some Haskell programming around the time, and I felt that both languages, although designing for completely different use cases, shared the if it compile, it works mindset. I've always hated this mindset because it's just not true. And what I mean by that is that there's invariance within your program. I mean, all of my toughest bugs are logic bugs. I called it. I know I've never liked this Rust mindset, and I don't understand how this Rust mindset has proliferated this long. Right? Like, you build anything that's sufficiently complex and your worst bugs have nothing to do with ownership or with one person mutating. It's almost always some other thing. And this is a very common Rust mentality. And I guess Haskell mentality as well. I just don't really like it. The fact that the borrow checker would be able to eliminate a class of issues that you encountered in C all the time felt magical. Yeah, fair. I mean, I will agree with this. The fact that, for those that don't understand how Rust effectively works, it's really, really simple. It's very, very simple. By the way, someone's saying that the worst bugs are race conditions. Perhaps they're race conditions, but the bugs on average that I encounter have nothing to do with race conditions. The bugs that I encounter are simply me not understanding how things change over time. Anyways, how Rust works in its most simple form is that you have to understand the difference between the stack and the heap. Everything is allocated onto the stack. Now, there are pointers into the heap. When your stack item goes out of scope, drop gets called on it, which means that if you have a function and in it you allocate something, say a string, which allocates to the heap, you're going to have a stack item that's going to be a fat pointer that's going to be the pointer plus the length, effectively. I'm sure there's one other item. I'm sure there's like capacity or something like that as well. I'm sure there's like some other thing when it comes to the capital S string that I don't know about, but whatever. It doesn't really matter. And when this thing leaves scope, drop gets called, and this gets dropped along with the pointer to the heap gets dropped, meaning it gets freed. So in other words, this thing gets, it's very easy to call free on items because you don't call free yourself. Free gets handled by Rust. So that means there was a malloc called here for the string. If you return the string, then no free is called. Instead, the free is then, that stack pointer is then returned to wherever the calling is, and then it keeps on going until its only stack reference gets cleaned up, and then the free happens, right? Malloc chills return, yeah, it happens. So that's like the basics of Rust. For those that don't know what Rust is, there you go. It's not that crazy. And so this makes a huge difference when you're allocating and deallocating, because there's just a whole set of really shitty experiences when it comes to doing this. But after exploring the language for some time, I gave up because the tooling was changing all the time. And quite frankly, I could not wrap my head around the borrow checker. Perhaps I was thinking in C too much. I think if you think of Rust as I just explained it, as stack and heap, honestly, it just makes life really simple. Like, if you think this way, it's really, really simple. Plus, 2015 Rust is much, much different. Fast forward to 2021, I started working with Rust professionally. I knew I didn't want to use C or C++, and Glauber, my co-founder, had good experiences with Rust, so I went with that. I was probably fighting with the borrow checker for 2 or 3 months until things started to click. I was thinking in C too much. I then discovered the send and sync traits and how they really help with multi-threaded programs. The tooling and ecosystem has really grown up since 2015. Absolutely. Rust 2015 versus 2021 that's a vastly different experience. After the initial learning curve, programming in Rust really became productive. Fair. For those that don't understand how Rust becomes really productive is when you first start off, you start fighting something called the borrow checker, and you can't figure out anything. And then what you realize is that if you are using just sync stuff, you just call .clone. And if you're using async stuff, you just simply hit it with the old arc mutex. And boom, you're done. Rust easy. That's it. That's it. It's that easy. Rust is a complex language. The more I write Rust, the more I feel that there is too much complexity. When you use traits or async Rust, things start to feel complicated. Perhaps I'm still thinking too much in C. I don't think you are. I think it is complicated. I think it is a complex language. What is an arc mutex? Well, arc stands for atomic reference counting, meaning that it has that same stack-based allocation, except for that stack-based allocation has a pointer to the heap where the thing is stored, and it has a counter. And that counter is an atomic int, not just a regular int. So when this thing gets dot cloned, this counter goes up by 1. When your stack variable gets removed, it gets dropped, this count goes down by 1. When it reaches 0, the pointer to the heap is then cleaned up. It's like it's pretty straightforward, right? Like it's a pretty straightforward thing, right? And a mutex is just a semaphore of length 1. Easy. You didn't know that? What are you, a loser? Yeah, welcome to the 90s. Yeah, welcome to the 90s, everybody. Shared pointer then. Yeah, it's literally a shared pointer. An arc mutex is a shared pointer. So shallow clones, yes. Clones clone the stack. Remember that. When you call .clone, it usually clones the stack, except for in Rust. Rust is a little bit more confusing. Typically, you clone stacks. You don't clone heaps. In Rust, you clone heap or stack depending on the data structure. Again, this is why I say that Rust is generally a complicated language, because you need to understand when something clones the stack versus clones the heap, right? So an arc clones the stack, not the heap. If you do string.clone, you clone the stack and the heap. Right? It's a little bit, yeah, it's a little, you just have to have all these you have to have all these like rules in your head to do effective Rust. All right, Zig as a modern C. I think sometime in 2022, I discovered Zig because of 2 projects, Bun and Tiger Beetle. By the way, Bun, Jared will be on the stream here shortly. In 48 minutes, Jared's going to be on the stream. And Joran was supposed to join us as well, but Joran did not. As I had done with Rust in 2015, I started to explore it. I quickly discovered that I really like Zig because it feels like C. It is. It literally does feel like C. But just as Rust, after initial exploration, I gave up on it because the tooling kept changing all the time and the ecosystem just wasn't there for me. I do agree. Zig ecosystem is probably the worst part about Zig, is that it's just like the tooling just really ain't there yet. And the ecosystem isn't fully fleshed out. But it's still a great language. In the summer of 2023, I wanted to give Zig another chance, partly because Glauber would not shut up about it. I also perhaps may have been hounding them about how great Zig is. I decided I would write a small proof of concept, a clone of SquealLite in Zig. As I started the work, I discovered that Zig is a low-level language. Not low-level in the way C is, but much lower level than Rust. But I figured that's acceptable price to pay because Zig just feels right. As I was working on a database, I needed a way to perform I/O efficiently. I was reading the Tiger Beetle source code, and then I discovered Michelle's libxev. Is this like a libuv style? And even contributed to it a bit. But after 3 months of weekends hacks, I ended up converting the code to Rust. I just felt productive again. Now, the real question is, did you feel productive because you're writing full-time Rust all the time? You're writing Rust for your entire workday. Like, I mean, the hard part about that is feeling productive is difficult. And I think Pekka will agree with this one. He'll agree with this take. If Monday through Friday you are writing in X, and then on the weekends you write in Y, X will always feel better, right? Like X will always feel better because you're just used to every last bit of it. That's just how it works. You cannot help it because weekend hours are much smaller. Wrong. Oh, camel, my camel. Shut up, TJ. And so there's like definitely that as a thing. Also, when you start using Rust, a very weird thing happens. You approach problems the Rust way, right? You want to use enums, right? You love some types. You love the idea of traits, right? You adopt a lot of very Rusty way of doing things, a very a Haskell-y way of doing things. And you just start to, you get kind of like stuck in a mentality. And it's hard to undo this mentality. Just like if you work with Go a lot, it's really hard not to try to use interfaces for everything. It's just because that's what you're used to doing. And so then when you start using interfaces for everything, and then you go to a language like Zig that does not have interfaces, you find yourself, you find yourself hurting. Why am I not ready to switch to Zig just yet? So why did I end up ditching Zig in favor of Rust, although I still like Zig a lot? For starters, comp time feels like a hack. Really? Crazy. Okay, so we interviewed Chris Latner yesterday. By we, I mean TJ and I. TJ streams, by the way. Comp time was something they modeled part of Mojo after. This is probably irrational, but I just don't like comp time very much. In fact, I would much prefer the legacy preprocessor macros of C if I can't have generics. Really? I gotta know more about this because this just doesn't feel right. Like one thing that's so incredible, and I talk a lot about this, that I just absolutely am just completely blown away by. If you go to Ziglings and you look at just like the basics of this, it's comp time here. Is duck, I think is the name of it. Yeah, this function right here, right? This function's a comp time function, meaning it executes during compile time. So possible duck is an any type. It doesn't know what's being passed into this. And we go down here and we get the type of my duck. This is done during compile time. Then I say, does this type have a function or has a declaration called waddle? Does this thing have a declaration called quack? If it has both a walk like a duck and quacks like a duck, it is a duck. And if it is a duck, we call quack on it. Now, here's the cool part. If you go up here and you see these three different things they created a duck, which has waddle and quack. They created a rubber duck, which has waddle and quack. Then they created a duct, which only has connect. They're able to call this function quack or is a duck with a duck, a rubber duck, and a duct, right? And because it's compile time, this generates three different functions. It generates the rubber duck version, the duck version, and then the duct version. And the duct version is just simply an empty function that does nothing other than returns true or false, which is pretty cool because that means it actually compiled this reflection call at compile time. Like it compiles it as opposed to running it during runtime. Like when you use Go and you switch on types, it's doing this switch on types and you have to do all this stuff at runtime, whereas this does it at compile time, which is pretty cool. Aren't macros also generating functions? Macros do not generate functions. Macros generate text. Whoever said that. Yeah, there you go. Macros generate text when it comes to C. So C just generates a bunch of text, and that's it. They don't generate anything other than, they're just text replacements. That's it. They're just flat text replacements. That's why when you have like an all capitals if define, it just literally replaces word with number, right? Define true as 0. This is literally possible. You can do that. You'll still end up chasing zigzag. I don't know if that was me thinking too much in Rust, but I ended up writing lots of silly bugs that ended up in segmentation faults that I then chased with the debugger. See, that's surprising. I actually got none of those. And I think one thing that allows you to do that, at least in Zig, I've literally so far in my game that I've been creating, I have yet to run across a single one, and we have a decent amount of that. I think one thing that makes that so I don't run into it is that whenever I do a game state, all my things that could be nil, I put a question mark in front of them. And so when there's a question mark in front of them, it means that I have to first check if it's nil or not. And so by doing that intentionally, I know that this cannot be anything but a potential null. And so I have to like work through that every single time. It adds all of that safety that I need when I need it. If I don't need that safety, then I don't have it, right? I don't have to have it because I know this pointer will always exist. I assume this would get better over time if I wrote more Zig, of course, but I've grown to trust the borrow checker. Yeah, you also end up leaking memory. Again, this is probably me thinking too much in Rust, but I ended up writing code that leaked memory all the time. Of course, Zig has really nice tooling here to catch them quickly, so perhaps not such a big issue. Yeah, Zig is fantastic in this. Let me just show you a quick version of this. Since we're doing this engine test here, I'll go here and see this. I'm going to erase that one defer statement. So I deferred the deinitialization of my game state, right? So I'm going to do that, and I'm going to go Zig build test. I may have a bug. Please don't have a bug. Please don't have a bug. There we go. One leaked. So it's showing me that I have a leaked item, and it's even showing me where my leak was. Like, look at this. All these creep creates were leaked. All these things were leaked. And if you go to the very top of the original leak, it's going to show you leaked this thing right here. Zig, line 20, right here. That was leaked. So I'm like, oh, I forgot to clean up the game state. I'm going to put that back in. It's gone now, right? If I go up in here and I see this and I just I forget to deinit my towers, or how about this one? I forget to deinit my creeps individually, but I deinit my creep data structure, right? Then look at this. It's going to tell me, hey, you've accidentally leaked 3 creeps. Right? It's going to show me all the places that I leaked it. right? Which is actually pretty cool. I don't know. I really like that. Like, I actually really like how all of that works. And I find that to be a very comforting way to program. And even if you run things in debug, it lets you know when you've leaked stuff, which I think is a pretty good general experience for being very C-like, right? There are no books on Zig. I really, really need a good technical book to learn a programming language, but there are none for Zig. Okay, this is super fair. This is super ultra fair. I find this to actually be probably the most compelling reason not to use Zig right now, besides for tooling. In contrast, there's a lot of great books on Rust and specific topics on Rust available. It just feels very hard to learn Zig. Completely fair. You want to learn async Rust book, right? There you go. Here's the entire book of everything that has to do with async Rust. Right? Like that makes sense. This is probably the most fair thing ever. Ecosystem is perhaps not there. There are 2 large Zig projects, Bun and Tiger Beetle. Well, now there's Ghosty as well. So he doesn't know that Ghosty is also, if you don't know Ghosty is Hashimoto's terminal. And they are great source trees to learn from. But there does not yet seem to be a large ecosystem to tap into like there is with Rust. Tooling is also perhaps not there. The toolchain Zig itself provides is great, but it keeps changing a lot like Rust back in 2015. But more importantly, third-party tools like GitHub Copilot. I feel like this sentence was forgotten, but more importantly, third-party tools like GitHub Copilot, something. Yeah, Copilot just doesn't do really good with Zig because it doesn't. I'm surprised that Pekka actually Pekka using Copilot is actually kind of a bit of a surprise. I thought Zig now has a package manager, so we only need to wait 6 years for Zig to be awesome. My guess is that within the next 2 years, Zig will have a lot of the problems finished. How do you NPM install Zig? Not really sure. Industry investment is not there. Rust is used across our industry. For me, the tipping points were when Microsoft started writing parts of Windows in Rust and Linux kernel added support for Rust. These 2 things alone mean that Rust is likely going to stay around for a very long time. In contrast, Zig does not yet have the level of industry backing right now. It does not mean that Zig won't eventually get there, but Rust is much safer and boring option right now. Can't argue against that one. That's good. Good. This is if you are only looking for things that are that have big industry adoption, totally reasonable. True. I don't feel like he gave any really good technical reasons though. I feel like I'm a bit surprised that Pekka did not go more into this. To me, it seems like he doesn't quite understand comp time, which is a bit surprising because Pekka might be probably one of the most talented engineers I know of. So I'm a little bit surprised by this. Vibes were off with Zig. That's how I do it. I really, really like Zig, but I am not ready to switch to it just yet. Rust is not perfect, but it's my go-to language for systems programming. I feel productive with it. Zig may be in the situation Rust was in 2015, and all it needs is more time. But for me, I'll be waiting for the first book to come out and then get back to it. I am also hoping that maybe they will dumb down the language for people like me and provide an alternative to comp time. But until then, I will remain happy Rustation. Well, I mean, you got to remember, like, I love comp time. I'm a bit surprised on the comp time hate by him because I feel like comp time is like the inverse for me. I feel like Rust's generics, their narrowing of generics through traits and where statements, and the difference between calling impl versus box and dyn, it feels like that is much harder to grok and be really good at all points than it is the other way around. What is comp time? Comp time is code that is executed during compile time versus runtime. Comp time is just metaprogramming like const expression and templates in C++. Yes, it is. And that's all it is. Very Ziggy. Surely I'm dumber than this Pekka fella. You are. And I don't think Zig needs to be dumbed down. I don't think Zig needs to be dumbed down either. Let's see. When do you need comp time? When you want to build a list of something or you want to do something. Example of comp time. I already just gave an example, but here's another really easy example of comp time. Here we go. An array list. An array list is this right here. Is a compile time function that goes in here and it returns a structure that has an allocator that does all the things it's needed to actually build the underlying array list functionality. It has the initial capacity. It has the DINIT. It has, like if you're in C and you want a list of integers and then you want a list of char stars, you have to build those lists individually. Instead, this thing operates, instead you build a list that operates over type T. And so Zig, I have an array list. And if I want a tower list, I create an array list of tower, and now I have a type tower list. So this is a struct This is a struct that was generated at compile time. Now I have this tower list, and so now I can have my list of towers, wherever that's at, towers. Yeah, it's really unfortunate that you have to write it by hand every time instead of having simple generics like Go. Yeah, but you can do much more powerful things than you can with Go. So it's like, yeah, Go is really simple, but that's because Go doesn't have deep support for generics. It has light support for generics, and that's kind of nice, right? Like, I like Go for what it's used for. It's a great web language. How does Go handle generics? Very lightly on functions, right? Let's see, cool kids call it comp time, dummies call it structural macros, C++ degens call it template magic. There you go. You get the idea. Trade-offs, yada, 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 yada. Can you mix type arrays? Yes, you have to use tagged unions, though. Right? You have to use tagged unions, and tagged unions will do that. How's the progress with chat versus Gypsy Tower Defense? Oh, we're getting very, very close. I'm going to do more today. So anyways, you turned thousands of people into Zig fans, and I'm looking forward to Stack Overflow Survey 2025. Well, let's go. Zig async is dead. Yeah, I'm not sure. Zig async is very, very interesting. I haven't used any async features with Zig. I've only just hand-rolled my own thread for input. So if we go here, I have my own, I literally have my own input engine that runs on its own thread, right? So I don't have async stuff because I'm not sure I really want async. I don't really want async. I don't really want to do anything with async. I know async await is really, really useful. Async await is also just really, really magical, and it's kind of a pain in the ass. And when you want two threads that just run independently, sometimes it's easier just to use two threads. Colored functions were a mistake. They're very, very difficult. Magical? It is magical because there's a runtime. You forget how these things work, right? So in JavaScript, it works with something called the event loop. The reason why you have async await. The event loop has a series of tasks that are placed into a queue. And this queue is executed one at a time, right? And so it pops this thing off, and once this thing fully executes, it then goes around and does some extra. There's like an extra micro task queue that it can also check and all that, blah, 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 blah. And then once it's done, it goes back on and pops the next task off. And so when you make a request, right, when you do a fetch, when you do an await fetch, that adds a task. This executes something that when it's finished, it adds a task to the event loop. Right? That's why you don't have to explicitly await a promise in JavaScript. Whereas in Rust, you have a runtime. You have an executor that has a thread that is running, and this thread is literally checking futures, right? It's doing something. It's actually running through and manually checking a bunch of futures like, hey, have you ran? Have you ran? Have you ran? Are you ready to run? Are you ready to run? And it's doing that. That's why if you block on the executor, none of your other threads work, right? They're all frozen in time because your executor is all broke, right? It's not super straightforward how this works. Go works much more like this than this. And so Go is kind of in this middle ground, which uses a bunch of threads. It just uses Go func to spawn these threads, and then you choose how to communicate on those threads, right? Go has work stealing scheduler. It's a little bit different, right? I don't quite understand how the scheduler works, but it's very, very interesting. Whereas Rust is much different. You actually have an executor that goes through and does a bunch of stuff. Green threads, someone's asking about green threads. There's hardware threads, which are the things that are going to be like your program running in the operating system. And then what you can do is you have a thread that schedules work. When you do .await in Rust, you got to remember that this relieves that green thread of its work to be passed back to the executor to then determine what next thing should be executed on this actual hardware thread. It's very, very complicated. It's not straightforward. I would not pretend to understand any of this other than from a very, very, very high level what's going on. And JavaScript is a lot easier to understand because it actually only really has one thread. Right? It only has one thread, whereas these ones have many threads. This has n threads, and I don't know how big those n's are. Are you sure that async await uses green threads? Yeah, it uses some form of green threads. In Rust. In Rust, it uses some form of green threads. Right? No problem. it's just not clear exactly how it works. Async await in C# is a nightmare. They're always kind of so green threads are hardware threads. No, green threads are like your programmed in version of threads. You have a thread that runs that takes some work and executes that work, and then takes more work and executes that work. Something a lot like this queue. You can imagine that you have a queue of work, right? You have 4 threads 1 through 4. Or we'll just say 1 through 3 because it's easier. And they're all asking for work off this one place. You could imagine this exists, right? And if this thing had a list of items, it would do some sort of mutexing, right? It'd have some way to ensure that you can't grab the same work twice. And then it hands this work to this thread. This thread executes this work while this work gets executed on this thread. And when it's done, it can ask for more work. Right? So that's the effectiveness of it all. Now, how it all works and all that, I don't know. I've never actually tried to program my own executor, my own thread runtime. So I actually genuinely have no idea how it really works in practical sense, just in a theoretical sense. Tokyo does not use green threads either. Well, it uses hardware threads, yes. But it also has a way to be able to take those hardware threads and execute tasks on. So where does a green thread start and where does a task stop? Right? Like, that's the problem. It uses a thread pool, correct. It uses thread pool and pieces of work. So it's like, when does it become a green thread versus when is it just a task? Like, do you see what I'm saying? It's like, it's a very confusing thing. Like I said, I don't have all the answers to it. I just know generally how it works. And so it uses a bunch of tasks and runs them on threads, right? Can I have more work, please? So it's just like, what do you call that thing? I don't know what that thing is called. Implementing a worker queue is a great project, by the way. I'm sure it's a great one. Set jump, long jump. Let's go. There you go. That's the name of the project. I would say that I would like to see Pekka give a much more detailed explanation for this. This just sounds like you're not using the type system good enough. The thing is that with Zig, the type system is opt-in rather than forced, meaning that you can have a pointer that could be defined as nothing, which means you could get some really bad experiences, but you could also say, hey, this pointer may not exist. And I think that's the big thing that I'm seeing right here. So if I go to my game objects, the most obvious one is this one right here, right? Like, I'm saying this pointer does not exist at construction time. It is potentially a null, right? Now, I could probably take this out and make this work a bit better, which I probably will. But as of right now, with how I constructed things, I had to do this. Anyways, so there you go. All right, hey, the name is the Primogen.